Exam scores in Professor B's class are typically normally distributed with a mean of 77 and a standard deviation of 7. So the problem tells us that mu is 77 and that sigma is equal to 7. Now we have Walter in this class and he scores an 88. We want to know what's the probability that a student would do better than Walter. So we want the probability of a score being higher than Walter's, which is 88. So we want a greater than 88. Right now, our scores are in terms of a mean of 77 and a standard deviation of 7. That means that we don't have a z yet. We don't have a standard normal. We just have a normal with some other mean and standard deviation. So we want the probability that x is greater than 88. So the probability that x is greater than 88, we want to make this now into a z so we can look it up in our table. We do that by subtracting our mean and dividing by our standard deviation. So if we take x minus the mean of 77 divided by our standard deviation of 7, and we do the same thing to the 88, 88 minus 77 over 7, what we're going to have now is a z, because our first expression there is x minus mu over sigma, which is equal to z, and we get greater than 1.57. To find the probability of being greater than a number, we can use the rule that our table is only less than, but that it's a mirror image about 0. So we can look for the probability that z is less than negative 1.57. So we'll look for negative 1.57 in our normal table, in the margins of the table. So here's our 0.07 column, and we'll look for negative 1.5 on the side. And we end up with a probability for this one of 0.0582.